Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We are probably, mostly done with the substantive part of our rendering update to 3D. We were previously just doing kind of flat 2D rendering, and now we actually have full 3D rendering. I am not sure exactly what we should be doing today, but I feel like the right steps, because now we're kind of in a little bit of an amorphous zone where we kind of want to do some cleanup and get a bunch of things back on track that were sort of in limbo due to that transition. I would say probably the most important thing is now to go make our camera work reliably and our room structure kind of work a little bit better. So I feel like that's what I'm going to focus on today. We'll see where it takes us. Obviously, maybe we end up somewhere else. But I think what I'd like to do today is spend an hour or two just getting the camera room stuff a little bit better straightened out so that it's not a weird kind of hacky system. It's always been a little hacky back in the 2D day as well. We never really sat down and made like a really good, here's where you're viewing, what's going on. Similarly, a typical thing that might happen in games like this is when you do something like, I don't know, you flip a switch or something and a door opens somewhere. There's like a little bit of a cutscene kind of thing where the camera might pan over and focus on it so that you can see that that's like it opened the store over here and then come back. Stuff like that we would like our camera to be able to handle properly, and we've never implemented anything like that either. So just designing a camera system and doing the code necessary to make all of that stuff work cleanly is a pretty worthwhile thing to spend some time on. And it's not super complicated, like it's not particularly onerous code once we've sort of done the work we've already done involving allowing you to set an arbitrary 3D location and view the world from it and all that sort of thing. We've already done all the hard work, so really all we're talking about now is just having a coherent structure that says, what is the camera doing right now? Where is it trying to focus? Does it need to move there? Is it far away? Is it trying to cut there or interpolate there? Just a little bit of basic AI logic on top of it. Not even, it's not real AI, just more like just a basic controller kind of a thing on top of it is all we're really talking about. But it's just going through the motions of putting that in place, and also the notion of rooms, having that be set coherently and having the camera be able to think about that coherently. So it can say like, okay, I know that I'm supposed to be viewing this room or this tile or this whatever. I know what that is in 3 dimensions. I know how to figure out the place I'm supposed to view that from. Let's go ahead and move there. And I think that's what we want to focus on first. When we get that done, then I think the other thing we want to do is the thing I mentioned before is just have the ability to knock out things that are in between the camera and the player, so that if the player is underneath a layer where they're on the second floor of a 3-story building or something, and that third story is in their way, that third story wants to alpha blend away smoothly. When they come up to that third story, it should blend back in. That sort of thing, I think we want to go ahead and enable in the renderer side of things. So I feel like that's kind of where we're at in terms of stuff that needs to happen. At that point, I think render cleanup and just putting in maybe some nice paths for stuff like particle systems or things like that. Just kind of rounding out that field and just making that feel like it's a little bit more finished and solid is really, I think, the complete package for doing the full 3D upgrade. And then I would say we're basically done with that, and we should move on to a different area of work, whatever that turns out to be based on what we feel like. So all right, today is day 377, if I'm not very much in error. Let me double check to make sure that that's actually true. Yeah, there you go. Day 376 is right there. So there we go. So I'm going to go ahead and open it up. Day 376's source code is what you're going to want to start with if you're following along with today's programming at home. And let's go ahead and just do a quick build and show where we're at. If I remember correctly, the last thing we did was draw room boundaries. Let's take a look here. Okay, there we go. And I think we also kind of said maybe someday we'd work out the math for the cross product in a little bit more detail. I'm not super motivated to do that today. I'm not interested in doing a lot of math grindiness today, so we probably will skip that till a different time, since we really don't care very much about the cross product in any particular way at the moment anyway. It's really just for drawing these little debug volumes is the only reason we needed it in the first place. So anyway, as you can kind of see, we're drawing debug volumes now. So we can, this is nice because now we can actually show stuff like where we think the rooms are. And so what I'd like to do is sort of move into basically like get a little bit more involved in the collision volume stuff and maybe set those a little bit more reasonably. For example, right now you'll notice what we're doing is we're setting like collision volumes on these trees. I don't really know now at this point what we're doing with collision volumes, but I think, you know, what I would say is based on the design of the game, we really don't need collision volumes for stopping you from moving, because when you move, you can only move to unoccupied squares, right? And everybody has to stand on squares. So really what the collision volumes are for is for floating objects, so basically projectiles and things like those creepy floating heads that are there. I don't know that we'll actually have any creepy floating heads in the game, but you know, we'll probably have things that are floating that do not necessarily occupy squares. And so collision volumes are really mostly for that purpose. What that suggests to me is that we probably don't need anything really all that complicated for our collision volumes. A simple, you know, cube, well, not cube, right rectangular prism might be the correct word for it, but basically like a three-dimensional rectangle is probably all we really need for our collision volumes at this point. I don't know that we need, you know, we did something a little bit more complicated. We had a way of you actually specifying a whole series of collision volumes where you could say, you know, I've got this many different rectangles and so on. We may just want to say that like every entity has a bounding volume, and the bounding volume is, you know, either a sphere or a rectangle or whatever, and that's just good enough for now. Because we don't really have any need for anything complex, and we're not, I don't think, going to, because like I said, most of what is actually the important collision detection that really has to be rigorous in the game is mostly about making sure that players and monsters occupy squares fairly, and that is taken care of with a different system. So given that that's the case, what I would say is I think we should be able to go in there and change that around. And then from there, what we could do is make sure that our room collision volumes are set per room correctly. And that'll be easier once we have in the entity struct its bounding volume represented directly in there, right? So that's all really academic at this point. I don't know why the find results window ended up down here. That's just the mysteries and the magic, the breathtaking magic of Windows, of Visual Studio. Let's see if that fixes it. Yeah, that fixes it. There we go. I think it's probably because we just didn't have a find results before, so it had placed it down there. So let's fix that, and there we go. So now I'll go and start doing the thing that I was talking about. So for starters, let's get room boundaries in there, and let's try to make those room boundaries work relatively well. If we go into Handmade Entity, then one of the things I think that we were doing previously that is not particularly great is we have the entity collision volume group, and that's stored off the entity as sort of this permanent storage, right? It's like what happens is we have different collision groups, and they are created at startup basically, and those collision groups effectively say this is, you know, what the canonical tree has as a collision volume. And I don't know that that's particularly interesting, like I said. At the very least, we would need scaling on there, because if we didn't scale those, there's no way to really represent the fact that each room has a different collision volume in terms of the room dimensions, right? Which is the problem that we're facing at the immediate moment. And so what interests me there is just figuring out, like, okay, we've got two ways we could do this. Either we stick with a version where we basically have a bunch of static collision volumes and you're just referencing the one that you actually need and having some kind of a scale value that tells you what that needs to be, or we just store a simplified collision volume directly in the entity. So for example, we can either say, here's the scale, and we apply this scale, like collision scale, to the collision volume, so that when the collision volume represents just a standard size, one tile by one tile by one tile room, and it just gets scaled out to fit the whole room or something like that. We can do it that way, or the other way we do it is we just have a rectangle 3 in here that's like collision volume, right? And these things go away. So I don't know which of those is the most useful, obviously, but it seems like this is the simplest way to go for now. And it allows the rectangle to be centered in any way around the entity. So even if the entity's position is on the ground, but it's a floating thing, we can represent that because the collision volume itself has a min and a max in all 3 dimensions, right? And so I think I just feel like that's probably what I would want to go with, because I feel like this is overbearing and doesn't really make a whole lot of sense, because I just don't see us needing it for anything, because collisions I feel like are just going to be more straightforward than that. Now, that may be a naive way to look at it, I'm not sure, but that's just kind of the way it feels at the moment. And I feel like the collision volume would give us enough tuning to figure out what we want the hit area to be for our guys and just leave it at that. Maybe I'm wrong about that, but, and again, this collision volume, rectangle 3, it gives us a bounding volume. We can then set that bounding volume and say, we could have a flag that says that, it's cylindrical or spherical or whatever. And so, we would have the opportunity to sort of fine-tune it to different shapes if we wanted to. It doesn't only have to be a rectangle. If we then find that a rectangle, for whatever reason, just doesn't fit certain entities in a particularly good way, if some entities are very rounded and want more of that, or more cylindrical, we can use that. And so I think, I don't know, that just seems like an easier way to go at the moment. So I'm thinking maybe we do something like this. And we just let that change propagate through, and I go ahead and I go ahead and sort of fix the problems where that would become an issue. So you can see here we've got this entity overlaps rectangles, and you've got this total volume here. And now the total volume is just a rectangle 3 anyway, if I remember correctly. So really, instead of total volume, all we have to do here, I think, is patch collision volume. That's all that really needs to happen there. Let's see here. Arg 2 from entity collision volume. Wait, what? It's a rectangle 3, right? Collision volume. That's the destination. That's an entity. What does it need to pass there? Hold on a second. Let me take a look at entity overlaps rectangle. So that takes an entity collision volume, and we don't really want that. To take that, all we really need to take at this point is a rectangle 3. What was entity collision volume? I'm interested to know. Let's take a look here. Oops. So it's just another version of rectangle 3, right? So that was probably just dumb, because at the moment we don't really need it. I mean, dumb is probably a wrong word. It was just thinking in terms of like, well, in the future maybe we'll mark these up or something. But at the moment, yeah, I don't think I really want to, like I said. So we really just get rid of this, right? And rebuild. So now what we would say is, yeah, all of these are not necessary anymore, right? Those will just get built right into the things that we actually want them to be. And all of this stuff will just be based on, yeah, the rectangle volumes and so on. So let's see. When we do the growth here, we have entity overlaps rectangle, and we have the volume and the rectangle. So this is the entity volume. And so really all we want to do is, in this case, we want to know if these two rectangles overlap, right? And we're translating this rectangle by this P. And so I feel like this is stuff we should have had in the math library. I don't know why we're doing it by Minkowski in this case, because it's not really necessary. I want to see... So you can see we've got intersection code here, and we've got intersection for rectangles already. So if all we want to know if two rectangles intersect, really all we have to do is call this, right? And we'd call the entity volume and the rectangle, and the only difference that we need here, right, we can go like this. all we really need to do here is we just need to move this entity volume so that it's over by however much p is. And we already have a way of doing that, right? We have offset. So we can just say like, hey, offset this entity volume by the placement of the entity, and then overlap it with this rectangle and tell us whether or not there was any overlap. That's all we really need to do there, and then we're done. So again, pretty straightforward. When we do update camera for entity movement, this is a function we're going to be redoing. So we don't have to worry too much about it, but at the moment what we can do is say, well, okay, again, we have the exact same thing in terms of instead of calling is in rectangle, we can just again do entity overlaps rectangle. We can in fact call the exact same thing. We can say if entity overlaps rectangle, right? And you can see us creating this stuff here in ways that we probably don't have to do anymore. We were sort of working with the fact that our stuff wasn't stored kind of nicely in rectangles before. Here's the test entity P. Here's the test entity collision volume. And then we just want to know if it overlaps the rectangle for the room. And so the in-room volume, let's see here, rectangular volume, test entity P. Entity P in this case, I guess this is the test entity if it is a room. So the test entity itself, I guess, the test entity, we're just doing entity to entity. So what we probably should have here is if entities, entity overlaps entity, right? Is really all we want to say. We want to say, does the entity that we're asking about overlap the test entity, which is the room? Potentially, right? If we made it through this if, then it's a room. And if so, then we're done, right? At that point, we can get the rectangle for the room out at that point and proceed. So, in fact, a lot of this stuff, is probably, this room delta here, which is the dimension of the room, is just the get dimension of whatever the collision volume is, but it's not offset properly, so really room delta is not the right thing, and all of this code is going to go. So I'm just going to mark this with like to do Casey stop using room delta and start using a controller, and that will fix that in large part. So all we need to do now is augment that entity overlaps rectangle call and say we've also got a similar one, which again is just another way of calling the rectangle intersection function, but making it easy on ourselves so that we just can call these and not have to think about it. We're going to say, hey, do these overlap? And it knows to grab the right things out. So again, exactly the same thing here. It's just a call to ask whether the rectangles intersect, which we've already implemented. And so here the difference is that we've got two offsets to do, right? So we want to know whether A's collision volume offsetted by A's position intersects B's collision volume offset by B's position, right? That's the only thing we're asking it to do, and we've already got all the code for that, basically. So let's see here. Oops, and this is in the wrong order. There we are. Oops. And off we go. So when we've got entities overlap, that was the function we were looking before at. And I guess we didn't know we had one of these. This is the one that goes through all of those, and this one is just not necessary anymore, right? Where is? So the epsilon, it looks like it grows these by an epsilon. Does anyone use that epsilon? Because we can put that. So nobody uses that epsilon. So we don't care about that at all. That goes away and it's been replaced by the new one that just uses the rectangles and doesn't use the volumes. So now let's see what we've got here. So here is what? This is our move entity call, which again, probably eventually we would replace. This was the one from a long time ago. It's just there for moving people. It's looping through these volumes, which it doesn't need to do anymore because it only has one volume, right? There's only one thing to collide against. So there's just one rectangle 3 here, which is going to be the first entity collision volume. Let me take a look at what we're actually doing here. So we've got volume and test volume. So really that's just, you know, how are they doing their p-values? How are they doing the placement values? I'm not really sure. So there's the relative. It's got entity p plus volume, offset p, test entity p. So it looks like they don't care about the volumes too much, I guess. And then we're testing. So the interesting thing about this is we have to get the centers of these, I suppose, in order to continue having this routine work the way it does, which is probably fine. So what I can do here is I can say we've got volume dim and volume p. And this is just going to be, again, we don't need to loop over the volumes because we know there's only one entity here, right? And so we just have entity, collision volume, and this is a get dimension call, which will return us how big it is. And this, we can do a get center call to determine where it's centered around. And then the rest of this code should work. We don't have to loop over the test volumes because we know there's only one. So again, we'll have test volume dim, get dim, test entity, collision volume, and test volume p, get center, test entity, collision volume. So once that's done, the rest of this code in theory should just work. And really all we do is we just get rid of the arrow, right? Because now we've basically derived those values from what we're storing. The relative, again, would do exactly the same thing. I guess it's entity p and test entity p. Oops, can leave those. We just need volume p, test volume p, right? And then all of this, again, not particularly useful code, but at the moment we might as well leave it standing. Oops. Indent, please. No. What's going on? There we go. So then, I think we're good. And that's about it. So now when we're drawing these, we know there's only ever one to draw, right? And what we can do is say, you know, if has area, and then go ahead and test it, right? Or rather, go ahead and draw it at that point. And then when we do push volume outline, all we really need to do is say, well, OK, we're going to get a rectangle 3. That's the draw volume. And that's, again, just going to be an offset of the entity collision volume and the entity's position. That's the volume we're going to draw. And off we go. Now, I don't know if we need to do any additional work there in terms of like the can collide has area stuff. There's a little bit, it's a little bit overspecified potentially. But if we take a look at what happens in here, for example, when we're doing this can collide, I'm going to go ahead and say that in can collide, we probably also want to do, if these are set, then we probably want another check, which is like if has area a collision volume and has area B collision volume, because if they don't both have collision area, then that's not going to happen, right? So yeah. So similarly in here, I think we don't have one of those for our three-dimensional case. Move to the more modern type names. So here's our rectangle 3. So in order to have area, again, the only thing that has to happen here is it's got to have something, it's got to have a span in every dimension. So it just has to have its min be lower than its maximum on all 3 bounds instead of just one of those bounds. So I think we need to change it to this style because we actually use vectors in these as opposed to hard-coded, because I think we wrote it a little later, so it was, there we go. And off we go. So now let's see in the semicolon stuff here, missing something, collision volume, yeah. So make simple grounded collision. Again, now these would just be like rectangle 3. where they are basically returning. Let me go ahead and modernize these as well. I like these new short type names that I switched to. I should have switched to them a long time ago. But I don't know. I always used to type it out longer hand. They're nice. They're nice and tiny. Anyway, let's see. We don't care about this because we don't need to push a struct into anyone's arena anymore. So all we're doing now is just basically doing a rectangle center dim. So we just do rect center dim. This is the center. This is the dim. And that's it. So now anyone who was doing a simple grounded collision before, who was using one of those, can just call this function directly and set their collision volume using that. It also means that we don't need the world mode anymore in here, which is nice. It's just like, hey, produce me a rectangle that conforms to the standard that I was talking about. So in here, when we do begin entity, entity collision equals null collision, that, again, does not need to happen at all. We can, in this case, just have it be zeros. So what we can say here is it's a rect center dim or a rect min max of just all zeros. And that's a non-collider. That's what it would be if it was cleared to 0 as well. I don't know if it gets cleared to 0 at the minute. At the moment, I don't know if create entity does. I should check to see what that's supposed to do. Let me just take a look, because it may be that that's redundant. Clear to 0 is a nice feature, so I may have obeyed it in this case. So we 0 struct that. So I think for now, let's just say, like everything else, it just gets cleared. So that's nice. Things get initialized with a non-colliding volume, which is good because we want to have to set a volume in order for them to collide, which is nice. So begin grounded entity, in this case, again, can just pass rectangle 3 for the collision volume in that case. And then when we set that volume up, there it is, and we're done. And then in all these cases where we would have been passing like Monstar collision here, now we can go ahead and actually just have these be called in place so we can adjust them to whatever we want them to be. We can, if we want to, and again, we could just make this a function call. So if I take a look in here in world mode, Monstar collision, instead of storing those like we were doing before. Okay, so it looks like Monstar and familiar and stuff, it looks like those don't actually have collisions. So maybe let's just get rid of that. Because it looks like that's just kind of annoying now at this point. Right? And let's go take a look here at which ones we actually have. So you can see in here, the only ones we have are these. So null, collision, body, glove, Monstar, and familiar, those don't exist, right? So Monstar collision, oops. My head is in the way. Monstar collision doesn't need to have a collision. It doesn't have one at the moment. Hero body collision also does not. So the fact that we set that to colliding doesn't make a whole lot of sense because it doesn't really. So I don't know why that's set that way. So that's weird. The hero head collision is supposed to be there, and here it is. So we should be able to put that in there and just say make simple grounded collision. Oops. And that's, just what we had passed originally. So we're literally just doing the exact same thing. So I feel like the body should not have the collides flag set, but maybe I'm being dumb. But since we're not colliding it, you can get rid of that. I also think now, I'm not sure why we would necessarily have volumes and not collide. I guess maybe for things like rooms, which may have volumes but don't want to collide. I don't know. We'll have to think about that a little bit more as we get further into the entity system. Hero glove collision doesn't have one at the moment either. So that can just go away. And also, this is not passed here anymore. It's just head collision volume equals make simple grounded collision. So that's fine. Let's take a look if anyone else has a Monstar collision. It looks like a Monstar does, but Monstars shouldn't have any collision now. And so now if we compile, we should get back to ones that actually do have collision. So there's the familiar. Let's take a look at what that was. So the familiar collision. Oh, no, the familiar does not have a collision? I thought it did. I guess that's why I can pass through things. So it probably should have one, but it doesn't at the moment. So we'll leave it like that until we add one. And I guess we would have to have it be set to colliding there. All right, so let's see. We should have a wall collision somewhere, right? There's the wall collision. So this wall entity should have a collision volume. That collision volume should be this. Nowhere else used it. None of these were used anymore. Obviously, that's not used. Floor collision. See what's going on there. So that's a little more complicated. That gets used in one place, and it's got a specific kind of volume that's used with it. Let me hold off on that one for 1 second. Let me see if stair collision is used. So add stair uses it, and here's stair collision. It does use make simple grounded collision, so that can just be entity. Because I don't think we've got any stairs in at the moment. I don't think we use those anymore, but we'll keep it in just for amusement purposes. So there we go. Collision volume is there. That should be it for that. And then we've just got room collision, which we definitely don't want to work this way anymore. So this one is the one we're going to be changing. The room collision volume here is going to have a better... Oh, so here it is. This is what we need it to do. So we want to call this here. Here we go. And that's probably, I don't know if that's right or not, but there we go. Make simple grounded collision. Yeah. So let's see if that looks like it's in the right place. All right, so room collision is not used anymore either. So now we're just down to floor collision. That's the only thing we have left. So let's take a look at that. So floor collision is used here when we're doing the room, creating the room. We've got it here. So it looks like it's still only used in that one place. Let me move out from behind my head there. There we go. And so we should be able to fix that pretty well. Now tile depth in meters here, we've got add wall. Tile depth is down here. That's typical floor height. So let's go ahead and put that in here. There we go. Same here. Oops. There we go. And floor collision, again, needs to be done specially. So floor collision is here. Let's grab that out. And just add that up here. Boop. Okay. So this all goes away, and we are left with that. We can then use that here. Oops, did I delete what that actually was, though? So make simple floor collision is just something that makes, I guess, I don't know what that does. And in fact, I don't know why does it even have a floor collision? Now that I think about it, I don't even think that's necessary because floors don't collide with anything at the moment. So I think that's actually just meaningless. All right, let's see. That needs a semicolon. Walkable dimension, that is just the XY for the dim. Okay, that's pretty easy. That's just collision volume. dimensions, oops, which only wants the X and Y there. I'm not sure what the walkable dim and walkable height bit is exactly. I'm not sure what we use those for. It's taxing my memory at this point, but we'll leave it in for now. None of this stuff has to be here anymore. That's gone. And we're done. So now, in theory, you know, depending on how much we messed up, we should have something relatively sane happening, but we probably messed something up. Let's take a look. So here we go. You can see that we've got a little bit of a busted piece here. You know, we're getting double translation on the drawing, right? You can see that. I think that might just be because we're offsetting those volumes and unnecessarily when we draw them, so it may not really be anything other than that. Okay, because the entity transform already does the transform by entity P, so we literally don't need to do anything. It's literally just that. I forgot the entity transform would already do that. So I think that's probably it. All right, so now we're back to something relatively sane there, as far as I can tell anyway. So now let's just figure out how to get our room stuff to be showing up a little bit better in terms of volume. So what I want to do here is I'm going to color these if entity flags and entity flag collides. I'm going to set it to one color, and if not, I'm going to set it to a different color. So I'm going to say color equals the standard color. But if it collides, we'll set it to something else. And this way I can just see pretty quickly what I'm looking at. All right. So pink things are colliding at the moment. Purple or blue things aren't. And now we can see a little more cleanly. I think those are our rooms. So if you look at our rooms right here, you can see that our rooms appear to be, I think, right? I mean, it looks to me like our rooms appear to be bounded properly. I mean, for the most part, right? The only problem that I see with the rooms at the moment is that they're lined up too high. So, you know, you imagine what we're going to do with these room structures, right? Is we're going to say, okay, what room are you in? You know what I mean? So we're going to try to figure out what room is the hero in so we can move the camera to view that room. And so if you take a look at what's going to happen here, you know, if we cut where we're cutting, you can see that line right there is where this is that room's lower boundary. If I look from the side, right, you can see where that boundary is right there. Right, you see what I'm looking at? And what you can see is some of the floor tiles for this upper room are actually in a place where technically, if you were standing on one, at least the bottom part of the entity would be outside of the room. And so I think what we want to do is bias those downward so that our notion of where the tiles are for a room, that tiles are always up in their actual room. And so, for example, what we're doing right now when we're creating these entities in world mode, when we do like add standard room here, which is our little room test code thing, you can see that we do that the z value. So this is the code right here for figuring out like where a tile is going to be placed inside the room. And you can see that we have the x and y are not jittered at the moment, which is fine because we're trying to make a tiled. We're trying to make something that looks pretty tiled for the most part. You can see here that we've got the z value. The z value is a random bilateral. If you just go up or down by 0.25. And I think what we want to do here is only go up, basically, right? Like I think what we want to do is say that this is going to be like a random unilateral, only upward. And then we'll set it so that the baseline for the room is like the distance down that piece is going to be, whatever the sort of depth of a world of a world cube is here, which is like, I guess it's 0.5 units downward, right? At least I think that's what that is. So if it's 0.5 units downward, then what that means is we want the room itself, right, to sort of bias those pieces upwards by that 0.5. So I think what we actually want to say here is like, okay, it's 0.5f plus whatever that random unilateral is, so that everything is always skewed upward. I think that's what we want anyway. Let's take a quick look at that. So here's what that looks like, right? And now you can see the floor is a much more sane place, right? So you can see that floor line is now, all of the tiles for that room are up in what would be technically considered the bounds of the room, and that feels a lot better to me, right? That seems like a lot more sane. What I will say is we've got an issue here in terms of our floor height, though. You can kind of tell that we've got this rather nasty situation where the depth of a room is pretty tiny, right? Like, I feel like we probably want there to be quite a bit more depth to quite a bit more space between the rooms. Basically, like more modern construction, we want the 12-foot ceilings, not the 8-foot ceilings, right? When we hop down here. But anyway, you know, as the hero kind of goes down in here. So yeah, I feel like we roughly have what we want now in terms of the room setup, but again, I feel like we want this delta, whatever this delta is here, to be, you know, to be bigger. I feel like it's just too tiny at the moment, right? I also feel like maybe there's not enough variation in the tiles now, because before we were going up and down by that, and I think now we want to be able to go, you know, because we were going up by 0.25 or down by 0.25 at a maximum. Then we reduced that to only going upward by 0.25. That's half the range it used to be. So I think what we really want to do is more like this, to, again, get a little bit more variation. I just wanted a chunky feeling room just for test purposes, right? You know, that kind of exaggerated that delta, and I think that's a little bit better in terms of what it might be at its most exaggerated, right? And so now we're kind of closing in a little bit on what I want to see happen here, but I think now we just want to make those rooms a little bit bigger, and then we can start to focus on the camera code and doing something useful with that camera code. In the meantime, I'm gonna, since I have allergies, as you know, I will blow my nose for a millionth time today. All right. So that's like, yeah, that's all pretty good, and everything is right. You can see even this one right here, which is pretty low down, is right on the baseline, which is what I want. So that all feels pretty good. These bounds here look really wrong to me. So I think again, we have a bunch of work to do with the projected rectangle stuff, and that stuff has to get fixed. So that's going to have to get improved at some point, but that's sort of a separate issue at the moment. That's the simulation bound information stuff. Some of it's right, like that's correct. That looks like the right simulation bound for the most part, but yeah, I don't know. All right, so I think all I want to do now is just increase that height. So if we take a look at what's going on here, you can see our abs tile stuff, right? Basically what's happening is when we do chunk position from tile position and that sort of stuff, I think our problem here is that the tile depth in meters is messed up. And so I think we need that chunk dim in meters.z to be different than what it is, right? It's not square at the moment, or rather it wouldn't be square at all at the moment, but that's fine because I don't think it is anyway. And so the chunk dim in meters, you can see typical floor height here. I feel like typical floor height wants to be very different. So I feel like, you know, typical floor height wants something else. I don't know that we're obeying that everywhere really at the moment. So we might need to do a little work on that. But if you take a look at what that expands out to now, that feels a little bit better to me game-wise. You know, maybe that's a little bit too much. I don't know. You know, but if those were floors of a building now, I just feel like that's a little bit better. It's not realistic, certainly. You know, I mean, you know, if that's the height of a tree, I don't know that a typical building height is going to be that much drastic. And maybe I can knock it back a little bit. let's say, to something else. So, you know, something that's more like this. I don't know how realistic that is. It's probably not at all realistic. But it feels a little bit better to me in terms of the height difference between rooms. Maybe I'll knock it back one more. I don't know, but it needed to be at least that much. The other thing that I think would be interesting, so for example, you notice we've got this problem here, right? And I don't know that there's much we can do about it just directly, where you've got when the hero kind of comes up upstairs, you can imagine what's going to happen here. He's going to clip through this geometry if he's relatively tall. We could tune it so maybe he doesn't as much, but you saw his head clip through there. I wish these familiars would leave me alone. Hey guys, could you just not? Everyone's blocking me. Okay, there we go. So when I come down here, right, you can see me hopping down. You can see that we poke through there, and the circumstance, what we're looking at here, right, is the hero standing on this this plate right here, but that Z bias that we have in there makes him poke through rather than not. And you know, it might be that that Z bias is just too high at the moment, and that just getting rid of the Z bias would get rid of it. But we don't really know what would happen there. It also is probably the case that the hero is too big for the square he's on, because he's actually, if you take a look at him, he actually kind of extends a little bit more. He extends too far to the side to even be on a single square. So you can see like he extends further outside the bounds of the square. So really probably part of it is that the hero probably needs to be a little bit smaller, or perhaps the other way to look at it is the tiles need to be a little bit bigger. Let me take a look at that here. Tile side in meters, for example. You know, it may be that tile side in meters kind of needs to be expanded out. You know, maybe that needs to be more like this. Or maybe it just needs to be that the hero needs to be shrunk. Right? But it feels like that would be a little bit better. And again, the tiles themselves, I guess, have to kind of be... Why didn't we make those proportional? I don't know why. That's a good question. I also don't know why no one's able to actually hop at this point. We must be using that as some kind of a search distance that's hard-coded. We have to get rid of a lot of that hard coding, which we'll do when we do the game code, so it's no big deal. But so if they were further spaced out, then I think we'd have less of a problem here as well. Because again, you know, the hero would not protrude into it so much as he would at the moment. So that might be better. But I think possibly the right thing to do there, because I don't know to think about it. I think we want the tile side to be what it was at the moment, and we just want the hero to be a little bit less poofy. You know, maybe shrink him down a little. So let's see. Let's go to entity here. Or wait, that would be in add piece actually. So it's in add hero when we construct the hero. It's hero, isn't it? Add player, not add hero. Inside here, you know, if we sort of tone down the size of the hero a little bit, see what that maybe is more reasonable in terms of width. At least now he fits inside a square, which is a plus, right? And so when he comes down here, that looks about right. When he comes down here, you can see like he kind of, well, of course the camera moved as well in this case, so it's hard to say exactly if it was back a little bit, but still it's going to go through there. And then when it gets down here, it's out. So it's really only that one stair, that second stair. But I don't know. We'll see what happens. Point being, what I was going to say there is we have an option of fixing that by actually sort of working around that problem, even in the case where the hero is large. We can work around that problem by actually having the camera help us. Because if the camera moved over to where the stairwell was when you went downstairs, then you would end up in a circumstance where it would be straight on to you and you would not get that overlap, right? So that's another option. For example, if we imagined in add standard room, if we imagined that we were already in line with the stairwell, which would be what? World position P, left hole, hole down to floor below. Here is, okay, so here we go, right hole. this part right here. If we were to set offset x to 0 instead of 3, so the stairwell was right in the middle of the view, then you don't get that problem, right? So you can kind of see how if it lines up with the camera, of course that is if I can get these guys out of my way. I should turn them off. They're really annoying, these saucy gentlemen, saucy, bodiless, disembodied heads. So if I come down here now, who is in my way? Why can't I jump down there? Somebody's in my way. I'm not sure why. Or maybe it's just that that stairwell is too high for some reason now. I'm not sure why. The difficulties of illustrating things when you haven't finished the actual game code at all. And all these heads are flying up towards me. It's kind of creepy. There we go. So when I hop down these, you can see now there's no problem with interpenetrating because, you know, just because of where the camera is, right? It doesn't have the same problem. And so what we could do is just force the camera to align, to move over to where you are when you go down a stairwell. Would be another problem, would be another way to avoid having that graphics artifact, because there's nothing we can really do about it. Like I said, it's just an artifact of trying to do some 2D, you know, stuff in 3D. We're making these sort of hacks to allow you to do some stuff that you wouldn't normally be able to do with a 2D art to make it appear like it's situated in a 3D world kind of nicely. And at that point, it's just like, well, you know, you're going to run up against certain places where it's unclear if there's really any way to hack it to make it not have an artifact. But sometimes what you can do is just like make it so that case doesn't happen, right? So all we really have to do there is go like, okay, can we do something where we'll force the camera to compensate for that fact and make it not cause a problem. So anyway, looking at this looks a little bit more right to me now. I feel like that gives us enough space here between floors to make it feel relatively right. Again, they're much larger than floors would be in, say, a building probably in reality, but I just kind of feel like for gamey purposes, you want there to be a lot of room there. And like the dungeon wants to kind of feel deep, like when you're going down, that it's quite a bit below you or something like this. So I feel like that's a little bit more right. All right. So that's really all we need to do with the collision volumes, and we've still got about 45 minutes left. So all we should really have to do now is move over to working on the camera, which I don't know if we'll finish today, but I feel like that was all we really needed to do with the collision volumes now that they're simplified and clear what they actually are. So let's take a look at the camera code at the moment and just see what's going on with it. So I believe we have in here so yeah, you can see this here. This is a note. It is mandatory that the camera center be the sim region center for this code to work properly, because it cannot add the offset from the sim center to the camera as a displacement, or it will fail when moving between rooms at the changeover point. That changeover point problem, I think, is also something that we can avoid here, because the camera now, update camera for entity movement, what we can do is probably make the camera be an actual entity with an actual brain that updates itself as part of the world update. I feel like that probably would just work, right? At least it seems like it would. Now, maybe it's better to keep it separate, because that means we can run it guaranteedly after the person moves, but anyway. So here's the code that we were using before, which seems pretty reasonable, where we say, okay, any room entity, let's see if the player's in it. So that way we know which room the player's actually in, right? And that's pretty straightforward. Let's get rid of room delta. And let's just use in room, right? Because the other things come from there in pretty much entirely, right? if we wanted to, we could actually do these outside by just saying, you know, whatever, it's in room P, right? So you just get rid of these. So now, if we know that this is the room that we're trying to view, and we know where that room is, then all we need to do is say, well, I'm trying to move toward that room, right? I need to move in the direction of that room. And I'm trying to remember if this to-do would still apply. Center to be sim region center. So yeah, I think this can go away if we just stop thinking of that room delta as a thing and just have the camera be the camera without any displacement. Because I don't think we need that for anything in particular. I'm trying to think if we do, but I don't think we do. It's an interesting question. Let's proceed a little further and find out. Anyway, so we've got which room we're in at the moment. And so we know where we would want to be in terms of where the camera should be. And then we know where the camera is, right? We know both of these two things. So essentially what we would say is like, OK, what we want to do here is track the world space position of the camera through the entire system. So again, it seems like we want the camera to be in the simulation itself properly, right? We want the camera to have a better notion to unpack itself relative to the sim region. And I think, is that what we're doing here? No. So what I want to do, I guess what I'm saying is, we have the camera's world position, and I think what we want to do is unpack it into the sim region, then update it as if it's an entity, and then pack it back and return that. I think that's what we actually want. So let's go ahead and try to make that work in a sane fashion. All right. So if this is the room that we're in, we should be able to compute essentially what I want to compute here is, you know, I've got a rectangle that represents the room, right? And if I've got a rectangle that represents the room and I want to view it, I should be able to come up with, oh, I forgot to put my little day heading in, day 377. At this point, what I should be able to do is say, what is the camera location that would most, that would be where I would want to view this room, right? And I should be able to come up with a target position for the camera, right? So if I have a target position for the camera, then I would know, OK, this is where I need to view the room from. And once I know where to view the room from, I should be able to take my current camera position, wherever it is, and drive it toward that location. And that way, it gets me out of this whole situation that I'm looking at here with the whole, like, you know, problem of room apron, clamp map to range, bounce height, blah, 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 right? I should be able to make a thing that just kind of nicely goes between one room and another room as part of the camera interpolation or whatever has to happen, and off we go, right? OK. So what I want to do here is construct that. Here is the two values I was getting beforehand, but I don't know that I really care about those that much at the moment. What I really want to know is, where is the room, right? And what is that rectangle? So what I want to do is I want to take the room volume that I'm viewing. And I can get that by, again, just doing an offset by saying whatever the in-room placement is of the in-room collision volume, that's the room that I'm trying to look at, right? Like, that's what I'm trying to view at the moment. And so then what I want to do is say, well, the camera should probably be centered around that. So the camera, or the target position, should probably be whatever the center is of that room volume, at least the x and y of that, right? And then I want to be up some distance from that center. Now, it's the ground, it's the floor that I usually look at of rooms. So really, we probably want to say it's something more like the center of the room volumes x and y, but it's probably the room values minimum z that we're looking at, right? And then what I want to do is I want to offset that by however far I want the camera above that room. So the target PZ value should probably be increased by whatever, I don't know, however much I want here. I'm going to, think about what I want that to be and probably base it on the size of the room as well so that I can frame the rooms nicely. Then I'm going to get rid of all this I was going to say crap, but let's say wonderful code entirely. And all of this stuff we're going to get rid of for now. So let's just get rid of all of this, right? And yeah, let's just say an in-room camera height can go away now as well. Because we'll just do that automatically for now. And so what we need to do now is, first, let's start by just snapping the camera directly to that location, right? So here's the region origin. Here's the room cam P. That's going to be that target P. We don't care about this at all. Or, wait. So camera has a separate offset, which we shouldn't need anymore, really. So I don't really want that probably anymore. Probably just want to do some other stuff with that separately. Let me take a look at that. So you can see here we've got this offset here that gets applied to things. And I don't know that I really want that in there anymore. Let me go ahead and set it to 0 at the moment. But we're going to come back and revisit that in a second. So here we are doing whatever it is we're doing, hopping around, having fun. Now, for whatever reason, because the cameras, yeah, so this is the part we'll probably have to take a look at, like I was suggesting, but that's okay. So you can kind of see the problem that we have at the moment is that if we want to move to considering the camera's location to being an actual physical location in the world, which is what I would like, what we then need to do is have a way for the camera to articulate to the game where it's actually trying to view, right? And that is what would tell us what the sim region should be, right? So what we want here is something that's like when we go in and do update camera for entity movement, we know this is the room that we're in. We want to basically say, here is the simulation region room center, right? This is where you should be centering that about. So we want something like, simulation center, and that should be like that. And we would say then, okay, the target P is the simulation center plus that 8 or something like that, right? And then what we can do is instead of having this offset, I can say that the camera simulation center is going to be equal to that simulation center, and the camera P is going to be something entirely different, right? Like so. And so if we go ahead and do something like this, I think that's a little bit better. That simulation center bit now allows me to say, like, okay, there's a world position P, there's a world position simulation center. And then we get rid of the offset. I think that might do the trick. So now camera offset is not going to be anything by default, unless there's screen shake or something going on. That's good. And what we need to do now is say, well, okay, we're doing this thing where we're saying the world camera rect is get rectangle at target, render group. We don't really, I think, want to do that anymore. And the screen bound stuff we probably maybe, might be something we actually want to do. But at the moment, that's not, this stuff is not what we want. We want to do something smarter here. So when we have our sim bounds and we do this sort of nonsense, we need to do this a little bit smarter here. We need to do this more reasonably. And in fact, what we could do is actually just store what that room's worth of size is as well. We could have sort of something that uses that. And so maybe we want to store that as well. At the moment, I won't do that just yet. But what I would like to do is say, all right, so let's take this world camera rect situation and let's, this is just garbage. We don't really want to do it this way at all. But what we want to do here is say, okay, let's figure out where in the world this is going to, the simulation region should start, which is coming from the camera, which is telling us where the simulation center should be. So when we do this, we're saying, okay, here is the camera P. This is where I want you to simulate around. We don't want to do that anymore, right? What we want to say instead is, here is, well, I guess I still want that. Here is the simulation center that the camera wants, which may not be necessarily where the camera itself is, right? We don't want the simulation necessarily to be centered around the camera because the camera might be moving around. We want the ability to specify here is where we're simulating and the camera is somewhere slightly different from that potentially, perhaps quite a bit different from that depending on the circumstances. So that's where we're trying to simulate, and then we just need to know how big of an area we're trying to simulate at the moment. Again, I'm not sure we want that to really be based on any of the things that we're talking about here. Probably what we want instead of that is something, we probably want something for rect center dim that's literally just this sort of thing. And I don't know that we even want any of that other stuff at all at the moment. All right. So let's take a look at what we get here. Of course, now we also need some way of initializing that simulation center. There we go. So now we've got all of them set, so the simulation center will actually be initialized to something, which is good. And so now we just need to fix the one more fact, which is that the debug offset stuff at the moment appears to be initialized to 0 in a bad way. So we're going to have to fix that as well. But other than that, I think we're good to go. All right. So one last thing. Let's go ahead and get that. So we've got the simulation center initialized. We've got the last P and P initialized, but we don't really need to initialize those for the most part because they should get set automatically at some point. I don't know where the player is. Do we know where where do we add the player? I don't really know. So we add the player wherever the sim region currently is, the closest traversable to 0, 0, 0. So that should be okay, probably. Anyway, so I want to take a look at that initialization of the camera offset because we get some problems with the debug camera. When we're using the debug camera, we need the debug camera dolly to be something reasonable, which at the moment it isn't. So let's take a look at that. Debug camera dolly. Yeah. So the part that's weird. So here's the thing that ends up happening. So at the start, because debug camera dolly is 0, we end up with this problem of the camera can't zoom in and out because there's no known focus point to it. So what we need a way of talking about how far you are away from the simulation center, which is a separate thing, right? So we really want this distance here, this camera dolly distance, and also the point that we're rotating around, like the pitch and that sort of stuff, also needs to be respective of what that center point is. So when we're constructing the debug camera, we kind of need to look at where that point is. Because now we just have a camera position, and we don't have an offset from that position. We just have a camera that's like sort of floating around. It doesn't have that sort of construction of here's the center point and we're back a certain distance from it because we got rid of the offset, which I think we want to do. I don't think we really want an offset on there. I don't know. I'd have to think about whether we should keep it that way, where it's got a pullback that it knows about. I'm trying to think of whether I like that or not. Because on the one hand, it's much nicer if you're just thinking about the camera as always having a particular position in the world, and you could just treat it like an entity. It's like, here's where the camera is. It's this entity in the world. It floats around, does what it wants to do. But on the other hand, it's also nice to be able to say, well, okay, the camera's focal point is the entity. So wherever we're looking at is the entity, you know? And the offset from there is just how we're sort of orbit viewing that, whatever that is. So it's really difficult for me to really say which of those I feel like is more appropriate. So I don't know, maybe I do like the idea of just an offset Z there. And I just don't want that to be the thing that we animate. So I do want the camera's position to move in the world for its focus point. I don't want it to laterally displace X and Y, but maybe I do want a distance displacement on the camera as a separate control so that the camera itself is, its focus point is the entity position of the camera, essentially. So that's the question, and I don't know the answer to that question. That's one that's like, I feel like it's one of those six of one, half dozen of the other, that whichever one you pick, there's going to be some difficulties you're going to encounter with the way you chose to do it, and there isn't one particularly right way. So I feel like either or. I guess at the moment, what happens with camera offset here? So, I mean, I guess what I could do is say, all right, if that was the case, I could still choose to do that. I'm just really not sure about it. But if I did that, it would look like this. And I guess technically it's redundant to say camera since it's in the camera struct. We all kind of know that. And then what we would do is say, yeah, okay, so when we update the camera position, we would say, oh, hey, by the way, the camera target Z is whatever we compute that to be. Oh, sorry, offset Z. And then that part would work properly, I think, yeah. Because then we would still be focused on the part that we're focused on, which is probably good. And the other thing that we can do there is now it's pretty trivial, I guess, to say whether we want a locked camera or not. So, like, for example, if we want to lock the camera to the player's location, we can also do that pretty easily because we can say, like, okay, yeah, if we want to make the target P be the entity P for whatever reason, we just can. And then we end up with getting back to a scrolling mode in theory. Or maybe not. That's supposed to set the camera P. I miss something? Do we not use... Okay. We don't use the camera. We don't actually take into account the difference between the two of those placements, do we? So we didn't really write this code when we set up the camera. We just assume that the simulation center is at the center of the projection as well, which is not true. So what we really want here, when we create the view for the world, so we create the orientation, we create the translation, you can see it happening here. This camera offset actually wants to be more, to also have the delta. Delta from sim, right? And so we want to have a thing there which says we have to put the simulation where the simulation should be relative to the camera center. So we need something like, what is that in the world? We've got that call that gets the difference between two things, right? It's like a subtract call. Here it is. So in this case, we want to say like, okay, take the world, and I want you to subtract the cameras. Which one is it? That. There we go. I want you to take the camera's position and the simulation region. And of course, this is the way we're going to be translating the world. And it looks like, so the way that we've written this here is the camera offset plus the camera dolly. So we're actually talking about where we're placing the camera, and then we're creating a camera transform from it, which means we're inverting this value, right? These are the columns, these are the axes and the placement of the actual camera. So what we want to do here is say, well, the camera is at this location relative to the world, and then we're inverting that to place the world. So I believe we want to say, tell us the delta between the simulation center and the camera's location. That's the delta that has to get applied in here, and off you go. So these have to be addresses of, and then I think that should be correct. Or not. What am I missing here? That is probably bad. Code that never gets run does not have an effect on your game. That's just something you should probably be aware of in your actual life. So anyway, so now we have the ability to scroll a room too. And what's worth noting here is now we can scroll the room, which we may want to do, you know, for large rooms or something, who knows, essentially for free there, because we can just turn that on and off. And if we ever want to turn it off, right, we just can, and it'll snap back. And we can make a gradual snapping back of it, right, if we want to. And now that's just a lot cleaner because the simulation region is not thinking about where the person is. They're just thinking about what room they're in. Which is really all we actually want there. So I feel like that's kind of good. I also feel like maybe that we could, again, experiment with turning that on and off. So one example, like I said, is if we wanted to pull the camera in line with the player when when the player gets to something like a stairwell, so that it's kind of in line with the stairwell, we could like tag certain traversables or something like that. Where it's like, hey, if the player's on here, do this thing. Or another thing is like, hey, here's a region that if the player's in, I need you to like pay attention to something that's happening. I don't know. Right? So what I'm thinking there is like, let's say, you know, I don't know if we're overloading this brain thing a little bit much. I think we probably are. But if you imagine doing something here where we're testing these entity overlaps, right? What we could do is test another overlap as well, which is to say, let's take a look and see if you're in any other regions that have special overriding camera concerns. that are different than the room concerns. So we could have like, you know, what room you're in, and then like, you know, special camera or something. And so we could detect if you're in the special camera region, and if you're in the special camera region, we could do something special, right? And for the moment, I'll just do a thing where we'll say if we're in the special camera region, then we'll do the switch to the entity mode or something like that, just to show how that would work. But then we'll do something, you know, a little bit better in terms of like detecting the camera a little bit more. I also, for the moment, might go ahead and switch us to optimized build so that we get a better frame rate. So we get 60 frames a second for testing, right? Just so we can see, you know, it's easier to test something like a camera when you're zipping along in a nice way. So, you know, here's the current state, and what I'll try to do here is just make something that's like, okay, let's say that when we hop to here or something, and go down the stairs or start going down the stairs, it'll switch the view to something that like lets us see that a little bit more easily, or I don't know, something like this. Not sure that this is something we actually want in the game, but just showing like how to start making the camera be a little bit more flexible in that sense. So if we make something like an entity here, and you know, maybe I make an entity flag or something to this extent, which I think is how I probably should have done the rooms as well. I don't know that they wanted to be a brain per se. That seems like a bad idea, but you know. We'll sort of start to clean this stuff up as we get a little further down the road. Anyway, if we have something like this in here, I could do something like, you know, like this. So that we can detect things that are going to be, you know, relevant there. We don't need that code anymore. That's not there. So now we can create volumes that control the camera in some way, right? And so the way that we would do that is in Handmade entity. In Handmade world mode when we're creating it. You know, when we create the stairs for add standard room. What we could do here is say like, okay, wherever the stairs are in this thing, let's just add another entity here that's going to be like specifically just for this test. We'll begin a grounded entity here, and we'll end it here. And the placement of this entity is, I guess, just going to be whatever this is, this P offset or whatever. I guess now that I think about it, this is really outside of this stepping too. So it's really after we're done, we would add it. And so we want to add something that puts you know, a volume in place so the entity can an entity that has that flag set whose bounding volume is like the region of the stairwell, so that when you go in there, you would, you know, it would detect that and do the right thing. So we want to set that flag first of all, so that it will know that this is something that's entity is going to control the camera when you're inside it. And similarly, you know, we need to set a bounding volume for it that sort of logically places it where it needs to be. So what I can do for that is say like, okay, we know the collision volume is going to be a rectangle of some kind here. I don't know what I have to work with. It looks like these p values. What does this standard room thing look like? Where is that? Standard room. So you can see we have these world positions here, right? So what I can do is just grab one of those and then create the dimensions that should fit around it, right? So we know where the hole is in the world, so the p-value for it would just be that the room, right, the result p, we know that the hole is at offset x 3. I guess these array values here, right? So plus radius, so you know we would want these indexes into it. So there's the x. there's the y. And we know that like the offset x in this case should be 3. The y offset should be the middle, which looks like 0, so it should look like that. That's the center of it, and we know the collision volume. I guess we can do a center dim in this case. We know it should just be centered just around 0, 0, I guess. Or that may not actually be true. Maybe we want to do a min-max. So what we want to do in this case is we know that the min is going to be, well, we know we're going to be only a half tile in x on either side, right? In fact, probably a little less than that even. If it's about overlapping the entity, we probably want it to be very small. So we probably want like an x, x dim to be something pretty small, like tile side in meters. It should probably be just a very small fraction of that. So it'd be like kind of thin, because it'll be an overlap test. So if we get close enough to it, it should be fine at that point. So tile side in meters, we know that the min is going to be, the negative x dim here. The max is going to be the positive x dim. Z-wise, our minimum is actually going to be down from our position, because we're talking about going down the stairwell, I believe, right? Because let me just double check. Yeah, because these are Z. This stairwell is created in a downward fashion. Not that it really matters. I guess we could do an upward one, but the downward stairwell means that the Z. I'm going to leave the Y for a second. The Z value, although I suppose this is also going to be constructed this way, because it's symmetric in Y as well. The Z values are going to be asymmetric. The minimum is going to be negative however far down it takes to get to the bottom of the thing. Probably, so it's probably like whatever that world's typical floor height, right? It's probably going to be, most of that is probably how far we would want that volume to be. And then here, would just stop probably maybe a little bit above the surface. So, maybe something like, and I think we get the world in here, right? Yeah, we do. So that all works relatively well. So the only thing we really need to figure out here, is this P relative to, what is this P relative to then? Is that world position P is not stored anywhere? Is that really true? No, it's stored. It's stored right there. I'm confused, is what I am. Oh, it's because this P is actually just a sim region P. Interesting. Well, I guess that's not that problematic. We just need to be able to do that mapping. So really, it's just this, because that already does the mapping for us. So I guess I can do that. So now we need a Y dim. And the Y dim in this case is going to be the tile side in meters as well, but it's going to be, I guess, it's 2 in either direction. And then typical floor height is actually in world mode, not world. There we go. And I think that should create it. Now we should see a bounding box up here there, right? And there it is. So it's a little wonky. Okay, so it's actually a less than or equal to 2. But that last one is actually the stair that you step on. I guess that's okay, because we probably want to do it when you get there. So that's probably fine. That's probably fine. So let's just see how that goes. So here I go over to it. So it sort of worked, but it took a little bit of time, took a little longer than I wanted for that to detect. I got to turn off these familiars. They're driving me nuts. How many of these are we adding? One per room, I guess. We're turning those guys off. They're driving me nuts. All right. So it seems like it takes a little bit too long. Like, that should be detecting it, but it's not. And so I'm interested to know, let me see, if we set the bounds wrong. Okay, so there's the problem is that's the only bounds we have on the hero right now because it's just the head that's actually a collider. And so this is too low, right? That needs to be, that needs to go up above where it's going at the moment. So if we take a look again at add standard room and just change a little bit how we're doing that height there. So you can see here, this is the Z extents. Why? I'm not sure what's going on here. I guess that's because things are offset artificially from there. So we're going to need it to be more than that. I guess what we can do is say, well, let's go ahead and make it extend up to the top of this room as well. Not all the way up to the top, but pretty far up. So now there's a pretty generous volume there. When we hop in here, now we're going to go down the stairs that way, right? And off you go. So hopefully that's fine. We still get a little bit of clipping there on that because, again, that guy is just really tall. I think that might just be the case that we need our Z-bias values to not be so big as they are. Is probably all that's happening there, right? So now, you know, but let's keep going on this front. Although I would like to see, so if the hopping was working, yes, so you can see it still kind of pumps through there a little bit. Let me take a look. I want to take a look at what happens when we're in debug mode. I wonder if debug camera should always snap to the location of the hero. It's probably the right thing to do. But you can see how much lower he is. So I think those Z-bias values are too high at the moment, potentially. So I'm going to just go ahead and remove those a little bit. So I think maybe the Z-bias is just too much. It's causing things to pop out way more than I think maybe they should. So I just want to take a look if that helps at all. Yeah, so that's better. Right? So now you can see that camera volume is doing exactly what we want, right? It's like when it comes in there, we're triggering the camera to go to a different location. The problem is, as you can see, like this is what I was saying, is like at first we'll just set the camera, set it to where the entity is, and off we go. The problem with that, obviously, is that when you do that, it's going to be very jarring. So, like, you know, if we were to leave it like that in the game, it would be very disconcerting to, you know, you don't really want that to happen. You just want the camera to maybe start to move over there, and if the player doesn't end up going down the stairs, then don't. And then, you know, if they just are breezing right through it, don't do it at all. If they start going down the stairs, maybe do it a little faster. Who knows? Like, there's a bunch of things we could be doing there that we're not doing, right? In that sense. And also, it's weird, the head doesn't... we need to work on a bunch of this stuff. It'll be nice to finally get into the game code and just do the... for no other reason than finish up all the animation stuff to be nice and solid. But anyway, because you can see the head doesn't actually go downward. Hardly at all. It floats downward at a very slow speed. So it stays up quite high. Let's see if I can demonstrate that a little bit better. See how slowly that comes down for whatever reason? Not sure what the reason is. Whereas that's how far down it should already be on the second stair, and it didn't even get there by the time it got here. So the spring on the head for vertical is just not correct at all. But anyway, that's neither here nor there. Anyway. So, well, all right. So I guess that's all we're going to do today, because we're now at the 5-minute warning. But tomorrow, I think that's pretty clear what we should be doing tomorrow is we should just go ahead and make the camera move smoothly so that, you know, it moves over gradually and then moves back over every time, you know, it wants to change position. It's being more gradual and it thinks a little bit harder about where it should be looking. Let's go ahead and go to the Q&A. And I had to reinstall this machine that I used to monitor the chat because Manjaro was dying a rather horrible death on me. And so I was wondering if someone could make it do Q&A in the Twitch chat. I don't have a login on this one yet. I can see the Twitch chat, I just can't type into it. Canucles, how's it going? Two questions. One, how come Rad aren't owning every avenue of compression in existence like video codecs? Okay. And two, is Handmade here at some point will be beautiful 2D animated like the excellent Hollow Knight that everyone should play, by the way? Canucles, I don't know why you always try to get me to play Hollow Knight. I played it. I did play it. I mean, I have it. I can't remember how I got it. I want to say that it was in some kind of a bundle or something, because I don't know that I actually bought it, or maybe it was on sale in like a Steam sale and I bought it. But somehow I did end up buying it, and I did play a little bit of it. That's about all I can say. I have not played much of it. As for whether it will be 2D animated, there's not going to be a whole lot of animation in Handmade Hero, probably, because most of it will be somewhat procedural animation. But we do have a bunch of art from Anna that we can put in, and so pretty soon, when I get a chance to build a new art pack, we will do that, because it's a lot better art for what we're doing as well. It's like at the proper perspective and stuff, so it will look more correct, which would be nice too. As for how come Rad aren't owning every avenue of compression in existence, like video codecs, I mean, the reason is because I think they do own the only ownable part of video codecs they do, right? They sell a proprietary video codec for games, and it's the video codec that's used in every game, pretty much. You know, there's very few games that don't use it if they show video. They can't own something like the MPEG spec because that's a giant patent licensing pool situation where nobody owns the codec. It's just a bunch of companies who are trying to extract royalty fees, and also companies who want to do video stuff themselves and are trying to lessen their patent royalty fees, get together and put a bunch of patents in and make a god-awful, heinous, giant codec that is a real pain in the butt to use. And that's the, you know, open standard, which is not really very open. And there's that. That's all there is, really. There isn't another market for video codecs out there. Nobody buys video codecs for movies because, you know, a Blu-ray disc has to have the Blu-ray standard movie format on it, which is going to be MPEG-4 or whatever, right? And that is a giant patent licensing, hands-off situation that, you know, you can't get into that market at all, right? All Rad could really do was patent a bunch of video things and then put them into the MPEG patent pool. But the people at Rad, you know, have the same opinion as I do about software patents, which is that they're bad for the industry, so they don't do that. So I don't know that there's anywhere else they can really go. You know, I'm sure they would branch out into another avenue of video compression if there was somewhere that you could make money doing it, but I really just don't know that there is. Sausage Superb, why don't you search and replace for the new short and sexy data types? I should probably. Maybe someday we will spend some time doing it. It just takes a while. Uh, oh, Hollow Knight. I'm sorry. I was thinking Shovel Knight because I thought you were the one who was always telling me to play Shovel Knight. Do you just only ever recommend to me to play games that are called something Knight? Hollow Knight I would very much like to play. I didn't know it was out yet. It's on my wish list, so maybe I don't know if I got a notification or not. I will definitely play Hollow Knight. I have not played it yet. But I will definitely be checking it out. Yes. Sorry, I got confused. Dead Beef. Is the camera for this game going to be plenty smart or just a little smart? In this staircase, I imagine you might want to measure the velocity of the player to not have it affect the camera if the player is rushing straight past. Yeah, I would say that's a pretty easy thing to add. I wouldn't say that's particularly smart either. So that's a level of smarts. Like that's not too smart for this, I think. Like I don't want to have some gigantic AI camera thing or anything, but that's a pretty reasonable thing we can add. It's not too smart on the smart. It's not too smart for its own good kind of thing. So I would be totally down with adding that. We just have to get a little further on to actually have the camera do any interpolation first to make that do it. But yeah, I mean, checking the velocity of the player is not too bad. You know, in terms of that collision, for example, if we, you know, in here where we say if entity overlaps entity, what we can do is just say like, oh yeah, you know, the inner product of these, like, I guess I could do it here. Not sure how I would want to do this exactly. Well, we don't even need to do the inner product really unless we specified a v3. So for right now, we could even do it even simpler. We could just say, you know, if the entity, which is the player in this case, if the entity's velocity, what do we have? It's dp, I guess. If that is in the y direction, not sufficient, let's say, you know, if it's less than some value, then, you know, or sorry, it has to be greater than some value in order to actually care or something like this, right? So we can definitely do that. And then in theory, you know, when the player's hopping along, it won't do anything there, but if they start to move down, it will, right? So something like that is really pretty easy for us to do. The only thing is, yeah, but in order for that to, in order for the camera to feel it all good, we have to add the interpolation, which we can do tomorrow. And maybe we'll say to do make entity parameters that control velocity direction measurement. But yes, so I do think that's a good idea, but. Fielda, is the debug text drawer order still inverted? It seems so by the looks of the debug text. Is the profile still working? Yeah, so we haven't finished updating the debug stuff at all. There's the clip recs have to be fixed in there, and the debug draw order has to be fixed. I don't know if that might be the only two things. I don't know, but we will fix them eventually when we're finishing all the cleaning up from the different camera stuff. But Team R&B, greetings Casey. Last week during the Wonderful Handmade chat, you demonstrated how to dynamically create code in memory. You have mentioned in the past how you do a fair bit of metaprogramming, and I always envisioned that you would generate C++ code to files. When you tackle metaprogramming, do you write out to disk first and then have it compiled, or do you do it all in memory, similar to what you did last week? I would like to do it all direct compilation, but I have never had enough time to really write a good code generator, so I don't do that. Typically when I generate code, I generate it and feed it through an existing C compiler somewhere. So, you know, if the rest of the project is being compiled with Visual Studio, it gets compiled with Visual Studio, or whatever. If it's LLVM, it's LLVM. I don't currently do any code gen. I would like to, and I have sort of the starts of some of that stuff that I've done kind of in my spare time, but I just have not had time to devote at work to it, to really making a good code generator for x64 that I can switch to, so that I don't have to use a traditional compiler anymore. At that point, it'd be nice because then I wouldn't have to use a compiler at all, really, because I could just parse the C and dump it into the code generator, and then you don't even have to use MSVC anymore at all, which would be nice. But there's just a lot of stuff that's involved in that. Debugging also becomes a problem at that point, right? Because generating x64 code is one thing, but you got to generate debug symbols. Because if you don't generate debug symbols, then you can't step into the code you generated in the debugger, and that becomes very difficult to debug, right? So, it's a lot involved. Hey Casey, I was messing around with 4x4 matrix multiplication implementations and whipped out 10 variations, some of which naive and others more optimal with SIMD. Out of curiosity, I performance tested them all on VC, Clang, and GCC. I was very surprised with the results, as the compilers seem to be doing very different things for this simple task. For example, on GCC, the naive version sometimes beat what I thought would be optimal SIMD. Seems like it was able to output better intrinsics, but on Clang, it was the opposite. MSVC seems to have failed at unrolling a loop, and all implementations were crap, except for a manually unrolled SIMD version. I realize this is a rat hole of a problem, but is this really where we're at in terms of philosophy of write once and let each compiler do the best thing for the platform? Any thoughts? I guess the first thing I would say is I'm the wrong person. There's probably a good rant about that somewhere. I am the wrong person to do it, and the reason for that is because 99% of my time is spent doing architecture and code to do stuff that is not 100% performance critical, right? As soon as you drop into SIMD, you're talking about stuff that's going to be performance critical. You're probably not going to be doing a lot of SIMD optimizations to the level where you're looking at what the compiler is outputting when you're not talking about performance critical stuff. And I just write a ton of code, and a lot of that code is not in that category. If you take someone like Jeff or Fabian, who live day to day a lot more in the we are trying to do optimizations to things a lot of time, I don't know exactly how much of their time they spent doing it, but I would say 20 or 30% might not be an unreasonable estimate of how much time Fabian or Jeff might spend thinking about something like how the stuff that they're writing is going to get executed on a target platform, right? Because again, they tend to do stuff like, okay, they'll make Bink or something, and there's a certain amount of code in Bink, and yes, that had to happen, but then at some point it transitions into optimizing Bink for lots of platforms and getting it to run well on lots of platforms and all these other things. And now you're thinking day to day a lot about those in very specific ways. So I'm kind of the wrong one to rant about that, and I think the right people to rant about that are people who have to deal with this day to day. But what I can tell you is I think for certain the state is very poor. Compilers, I would say there's two separate things. One is that compilers are not very good at it, and the other is that the languages are not there. If you think about it, C with intrinsics, which is the current state of the art as far as that's concerned, for day-to-day programming, state of the art's the wrong term. It's the current thing you mostly have to work with, right? Because you can't be introducing all these specialized assemblers or something else into your tool chain. You've got to program day to day. You're talking about code that's get checked into a code base that gets compiled with Visual Studio or Clang or something, right? All you have to work with is intrinsics. Those intrinsics don't really do a very good job of either A, making it easier to specify what's going on, or B, being able to manhandle exactly what's supposed to happen. As a result, you do end up in situations where the simple code you would write that should be relatively clear how to make it work, and very straightforward optimizations like loop unrolling you might want to have happen, often can go horribly wrong when the compiler gets its hands on it, and that's unfortunate. That's why we have things like IPC or whatever it is, is that what it's called? The Intel compiler that is made for doing wide, versions of things. That's why we have some of those markup things available where you can more easily mark something up and the compiler knows what you're trying to do and it can generate good code for it. Those things have not mainstreamed as well as they need to, right? And so now you're constantly in this situation of like, well, maybe, we can go compile this part of the code on this other compiler and get better default behavior. Unfortunately, that's not the default thing. Again, I think this is mostly because most programmers who probably affect the C++ specification are not game programmers, and more specifically, they're not game programmers like the people at RAD who spend most of their time having to deal with this stuff. They're probably people, well, they're not people like me, because the C++ standard wouldn't look anything like it looked like if it was me, but they're people whose job duties look more like mine. They're writing code where the performance critical parts are very uncommon in terms of the amount of code they have to write. So they're not focusing on that, and they're not pushing that as hard as they need to get it to a better place. So, I'm sure if someday maybe it would get there, but it's probably not where it needs to be, and that probably explains most of what you're seeing. However, again, I can't really rant on it because I'm definitely not the right profile of a programmer to really even say how bad they are. Sometimes I do drop into assembly and look at what's getting generated for certain things, but that is such a rare day for me given the enormous amount of programming I have to do every day. The amount that's performance critical is super tiny on the current project I'm working on, right? So that's just a reality of the type of project I happen to be working on. And it does happen, but it's just really rare. And so I'm just not in a position, I don't have enough day-to-day experience with it to really say, here's what these compilers are doing and why. I do think that the place that this hurts the most, oddly enough, I think at the moment is not so much on PCs where you have so much heavy iron performance a lot of times. Tons of cores, really wide SIMD, out-of-order execution, giant caches, blah, blah, blah. The place where you really feel it is in the poorly designed mobile chip market, right? Some chip designs are probably quite good. I've heard that Apple's A9 is pretty amazing, for example. Other chip designs out there, apparently not so good. And it ends up being really important how you schedule your instructions or whatever on some of these chips, because they're really bad at working around poor assembly. An Intel chip is very good at working around poor assembly, right? It doesn't mean that better assembly, better instruction streams aren't still better. They are, but the chip does a tremendous amount of work to handle bad code well. That doesn't become the case on some of these chips in power constrained. They're less mature architectures. They maybe have less good engineers working on them, as the people, who knows there's only so many great chip architects to go around, blah, blah, blah. In those scenarios, you may end up in situations where the degree of meticulousness of the code that you can generate on those platforms can make a huge difference. And that's, I know I've heard some things without naming names of chips or the people complaining about them. I know I've definitely heard some things about stuff like that where it's like, yeah, okay, so would we like better ability to compile things on x64? Yes, but x64 is super powerful a lot of times. Would we like better things to deal with this random phone that happens to be a common Android phone or something? It's like, yeah, that's where we really need it, because it hurts us really bad there when we fall off the good path. And the compiler is generating like a lot of stuff that falls off the good path, Ms. Fielder, I remember you mentioned at some point that you were really interested in Salt and Sanctuary. Have you played it? I don't think I ever mentioned that. I think you're thinking of someone else. I did not work on that game, and I have not played that game, and to the best of my knowledge, I've never been interested in the game either, unless I have been forgetting something. Where does Null? Could you please explain once more why you did keep camera offset Z? Is it for movement between tile maps or something else? So the reason for that is really very straightforward. It's unclear whether it's a good idea or a bad idea. The idea behind it is just that, well, okay, so the way that we view the game is like this. Here is the world, here's the trees, whatever, here's the hero on it. The way that we view the world is you've got a camera that's looking down on things, right? And there's the hero. And so the reason that I thought the camera offset Z, what I wanted to do was go from a version where we were talking about the center of the room as where the camera was, and then we had an offset that would move the camera around to wherever we actually needed it. And I wanted to change from that to something where we know where the camera is for real, and the camera has its own real position, and the simulation center is something else, and it may or may not be looking at that. However, it does make a difference which one we want to encode, the focus point of the camera, like where it's looking, or the camera itself. And what I decided to do was encode the focus point of the camera, which can still be somewhere other than the simulation region. So, if here's the map, we may be looking over here, but simulating based on this, right? So the camera might be looking here. So like in the case of where we moved on the stairwell, for example. But the question is, do you encode the location of where you're looking from or where you're looking to? And what I decided to do was encode the location I was looking at, which means I need just that pullback, because we don't allow the camera to slide relative to its focus point, but we do allow it to pull back. So really that Z is just how far back we're pulling. And the reason that I wanted that to be encoded is because I feel like that might be a value that wants to be encoded separately for like bounce movement or something that I want to encode as a separate piece of the coordinate just to make it easier to deal with. That's it. More85, if it's off topic, I'll ask tomorrow during pre-stream, but follow up on devirtualization. Your main criticism about virtual functions was the overhead you get from the indirection. That's not true. That is not my main criticism about virtual functions. My main criticism of virtual functions is everything. There's the overhead is bad. The way it is stored is bad. It is not serializable. You cannot control the virtual function table yourself. There's tons of problems with virtual functions. That's not the only one. You can't make things fit in the same amount of space if you want to, so you can't use like packed arrays correctly, blah, 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 blah. So there's tons of really bad problems with virtual functions. They're only useful in very specific circumstances, and the speed hit is by far not the biggest one of those. The speed hit is actually the most unlikely one for me to complain about, because in a lot of cases you might use virtual functions, you might not care about the speed, because maybe you just don't have very many calls, right? So the indirect call is not the bad part of virtual functions. It is a potential bad part in some circumstances, but it's by far the least offensive part of them, because calling through a function pointer and calling through a virtual function are usually not that different. There's a double indirection in a virtual function, so it could be bad. It could be worse potentially, but it might also not be worse. It depends on the circumstances, so it's hard to say. Certain chips, it's real bad, but the x64 isn't one of those chips, so... Alright, I think that's basically everything. Alright. I'm going to go ahead and close it down. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with a source code if you want to play around with it yourself. We also have a forum site you can go to ask questions, a Patreon page you can go if you want to support the video series, a schedule bot which tells you when we're going to be live, and an episode guide maintained by the fabulous Miblo, which tells you pretty much what we did everywhere. There's also a crazy search feature that I don't know if it's in there yet. I don't think it's in there yet, because I think they're still working on it. You can see here that this is the episode guide table of contents. There's like a search thing coming too, which is kind of amazing. I don't know if we've got a demonstration of that, but it's nuts. I was playing with it the other night. This is, I think, going to get into introduced into the episode guide at some point. But basically, it's kind of crazy. You can go here and you can type in like anything you want. Asaf Gartner did this as an interface to Miblo's episode guide. But you can do nutso stuff. Like you can say like virtual or virtual function or something, and it shows you the times that I've talked about it, and you can like click on it, and it jumps right to the time that I talked about it, right? And it even has like a time-coded thing where you can jump to different parts of where I was talking about it. It's just crazy. So yeah, that's coming soon too as well. I don't know when that actually is getting integrated in there or what the plan is for that. I should probably ask Miblo what's going on with that, or Asaf. I don't know what the status is of it, but it's pretty amazing stuff. So the stuff that people are doing with the episode guide is just crazy. It's way beyond anything I was ever expecting to have as a resource for pulling stuff out of the archives, but there you go. So definitely check that stuff out. I will be back here tomorrow. I think we're doing a 10 a.m. stream tomorrow. Hope to see everyone here for that, and we'll maybe work on some interpolation code to make our camera a little smoother there. That's about it for now. I will see you back here for that. Until then, have fun programming, and see everyone on the internet. Take it easy, everybody.